Yeah. Okay, and then we can post it for the people who missed it because it's important. Well, every class is important, right? Every class. Hey, let's I miss you guys. I'm so sorry. I kind of, I hope you weren't too disappointed this week. But shit happens and that's what happened. So, but I think we're fine. We have plenty of time to complete um, this final section. Actually, we have an extra day or so to actually explore maybe a little bit of vanilla JavaScript. But for now, this is our final section that we'll be doing in P5. And but before we start, let's thank you, Camille. I'm gonna share screen and I want to look at your games. It's been so long. Oh my God. It's been so long. Let's take a look at your games. Da-da-da-da-da. Kids collab. Go over here. Here's one. See Ryan's. Private sketch. More, more. Okay. Okay, here we go. Okay, so A is left, D is right. Interesting. Okay. Start game. A. Ooh. Oh, that's kind of hard. Oh, and he has feedback and everything. Oh, awesome. And all I have to do is get into, ooh, gets faster. Oh, that's really cool. Let's try it again. Okay. Start game. Oh wait, oh my buttons, my buttons. And that's good because it gives it enough of a target zone. You don't have to be right on the money, you just have to touch it. Oh, it gets faster. Oh, that's hard. Okay, I beat my high score. Ooh, good for me. All right, let's see what else we got. Caleb. Star catcher. Are you using HTML elements? Is that what? No. Is it? Looks like a HTML button. Okay. Oh my gosh, this is hard. Oh, and you have varying speeds on them. I love it. Oh my God, this is hard. Ah. Oh my God, oh my God, oh my God. You guys should really try playing these on your phone. It's fun. Oh geez. Oh my God, oh man. What's the timer? Okay, 5 seconds left. 5 seconds. Okay, that's a good score. Okay, I'm taking that. That's a good score. Awesome. Okay, Andres Gonzalez. Oh yeah, here. Lava chicken. Okay. Space or up arrow to start. Controls up is jump. What did you do? Whoa. This is no raindrop game. Okay, what? Okay. Up is jump, down is crouch. Oh my God, I'm scared. Okay. What's gonna happen? Um, Nothing's happening.
I
Oh.
am Steve.
Oh, Jesus. Oh my God, this is
I
crazy. Oh
am
my God, wait till
Steve.
I show this to my son. He's gonna flip. Oh, this is kind of a different layout from the last one. Did you
I
randomize it?
am Steve.
And I died again. Wow, this is so cool. La, la, la,
I
la,
am
chicken.
Steve.
Steve, I'm a chicken. It is randomized. Dude, this is amazing. Oh my God. I can't wait to show this to my son. Maybe this will convince him to let me teach him to program. He doesn't think he needs to know. Wow, that is awesome. Double extra credit for that. That is so cool. All right. Karina, what we got here? Game over restart. Yeah, here we go. Yeah, this is working. Oh my God. Not very long. It doesn't give me a chance. We do it again? Yeah, okay. All right. Oh, it's only a 5-second game? I want my quarterback. No, still, you got the job done. You got buttons, you got things falling. Um, yeah. Wait, okay. Wait. Chat is in my way. Go away, chat. Chat, go on. Hold on. Waiting. Oh, come on. Okay. Oh, there we go. Okay, I got it done. Okay. All right. Moving. Thank you, Karina. Aaron, always reliable. Okay, we're gonna play welcome. Oh, it says welcome. You play. Oh, you got your the click area on your button is a little bit off. Probably wanna. Oh, okay, cool. All right, so it's a short game. It's a 10-second game. Yeah. Yeah, it's easier to when you're in development mode to like make them really short so you can test them. Yeah, very cool. Yeah, you got the job done. Very good. All right, what else we have? No. All right then. Okay, cool. All right, let's do this next one. Before we get into the actual code. What we're doing basically in this next section is we're dealing with data, and the object is we're gonna complete some sort of data visualization. Okay, so we're going to learn ways to store large amounts of data into like one kind of, it's like an object. Basically, it's called an array. It's basically a list. Okay, it's sort of a group of some sort of variables. They could be numbers, it could be uh, strings of words, it could be objects. That's when it gets really fun. Um, and and we're going to be creating some sort of data visualization and the whole field. Like you know, I think it would be awesome to just teach a whole class in data visualization. Like, because you can really get lost in it. And data visualization is basically when you have large amounts of data, um, and you find some way of visualizing the data. I know I'm still sort of repeating the word, but you take that data and you translate it into visuals, hopefully in a way that sheds light on that data, that gives that data some sort of meaning. So like the best data visualizations are when you actually understand the data better by experiencing whatever the designer, chose to display it as. So imagine you have like a huge spreadsheet of numbers just staring at that spreadsheet. It's going to take you a while to like really put A and B together and see patterns and things like that. But if we start applying, I don't know, lines, shapes, colors, text, whatever, and organizing it in a more visual way, things really start to pop out. So there's also a thing called infographics. Okay, data visualization and infographics are very, very similar. The names are kind of interchangeable, but there is kind of a difference. Infographics, you've seen, they do the same thing, right? They take data, turn it into some sort of visual, put labels on things. Think like a pie chart, a bar chart, something like that. Maybe something a little bit more creative and interesting. But the kind of like the difference between um, uh, infographic and data visualization is like a real data visualization. The designer may not actually know what's going to come out of it until they run the code, until they run the program, or however they've decided to. I mean, you could do it by hand on paper if you want, but you've come up with some sort of system, then you implement that system, and then you sit back and you look at it, and then you understand the data. Okay, that's like a true data visualization. An infographic, kind of, it's similar, but really the designer actually does understand the meaning of the data from the beginning, and they are molding their graphics to um, sort of express that meaning. So they kind of already have an understanding of the data when they're starting their project. Kind of a minor detail, but it's there. I want to show a video. That's kind of why we're meeting online, because I can connect to EduRoam right now, and every time I try to run a video using my phone as a hotspot, this has happened before in class. I'm going to show this video. It's a TED Talk by this data visualization designer. Let me turn on the. Oh, it disappeared. Okay, turn on the sound. Okay.
It feels like we're all suffering from information overload or data glut.
Can you guys hear
And
that?
the good news is there might be an easy solution to that, and that's using our eyes more. So visualizing information so that we can see the patterns and connections that matter, and then designing that information so it makes more sense, or it tells a story,
Great, thank
or
you.
allows us to focus only on the information that's important. Failing that, visualized information can just look really cool. So let's see. This is the billion-dollar-ogram. And this image arose out of frustration I had with the reporting of billion-dollar amounts in the press. That is, they're meaningless without context. 500 billion for this pipeline, 20 billion for this war. It doesn't make any sense. So the only way to understand it is visually and relatively. So I scraped a load of reported figures from various news outlets and then scaled the boxes according to those amounts. And the colors here represent the motivation behind the money. So purple is fighting, and red is giving money away, and green is profiteering. And what you can see straight away is you start to have a different relationship to the numbers. You can literally see them. But more importantly, you start to see patterns and connections between numbers that would otherwise be scattered across multiple news reports. Let me point out some that I really like. This is OPEC's revenue, this green box here, 780 billion a year. And this little pixel in the corner, 3 billion, that's their climate change fund. Americans, incredibly generous people, over 300 billion a year donated to charity every year, compared with the amount of foreign aid given by the top 17 industrialized nations at 120 billion. And then, of course, the Iraq war predicted to cost just 60 billion back in 2003, and the mushroomed slightly. Afghanistan and Iraq mushroomed now to 3,000 billion. So now it's great. Now we have this texture and we can add numbers to it as well. So we can say, well, a new figure comes out. Let's see, African debt. How much of this diagram do you think might be taken up by the debt that Africa owes to the West? Let's take a look. So there it is, 227 billion is what Africa owes. And the recent financial crisis, how much of this diagram might that figure take up? What does that cost the world? Take a look at that. Douche. I think is the appropriate sound effect from that much money. 11,900 billion. So by visualizing this information, we turned it into a landscape that you can explore with your eyes, a kind of map, really, a sort of information map. When you're lost in information, an information map is kind of useful. So I want to show you another landscape now. I need to imagine what a landscape of the world's fears might look like. Let's take a look. This is mountains out of molehills, a timeline of global media panic. So I'll label this for you in a second. But the height here, I want to point out, is the intensity of certain fears as reported in the media. Let me point them out. So this, swine flu, pink. Bird flu. SARS, brownish here. Remember that one? The millennium bug. Terrible disaster. These little green peaks are asteroid collisions. And in summer here, killer wasps. So these are what our fears look like over time in the media. But what I love, and I'm a journalist, and what I love is finding hidden patterns. I love being a data detective. And there's a very interesting and odd pattern hidden in this data that you can only see when you visualize it. Let me highlight it for you. See this line? This is a landscape for violent video games. As you can see, there's a kind of odd, regular pattern in the data, twin peaks every year. If we look closer, we see those peaks occur at the same month every year. Why? Well, November, Christmas video games come out, and there may well be an upsurge in concern about their content. But April isn't a particularly massive month for video games. Why April? Well, in April 1999 was the Columbine shooting. And since then, that fear has been remembered by the media and echoes through the group mind. Gradually through the year, you have retrospectives, anniversaries, court cases, even copycat shootings, all pushing that fear into the agenda. And there's another pattern here as well. Can you spot it? See that gap there? There's a gap, and it affects all the other stories. Why is there a gap there? You see where it starts? September 2001, when we had something very real to be scared about. So I've been working as a data journalist for about a year, and I keep hearing a phrase all the time, which is this: data is the new oil. Now, data is a kind of ubiquitous resource that we can shape to provide new innovations and new insights, and it's all around us and can be mined very easily. And it's not a particularly great metaphor in these times, especially if you live around the Gulf of Mexico, but I would perhaps adapt this metaphor slightly, and I would say that data is the new soil. Because for me, it feels like a fertile, creative medium. Over the years, online, we've laid down a huge amount of information and data, and we irrigated it with networks and connectivity, and it's been worked and tilled by unpaid workers and governments. And all right, I'm kind of milking the metaphor a little bit, but it's a really fertile medium. And it feels like visualizations, infographics, data visualizations, they feel like flowers blooming from this medium. But if you look at it directly, it's just a load of numbers and disconnected facts. But if you start working with it and playing with it in a certain way, interesting things can appear and different patterns can be revealed. Let me show you this. Can you guess what this data set is? What rises twice a year, once in Easter, and then 2 weeks before Christmas, has a mini peak every Monday, and then flattens out over the summer? I'll take answers. Chocolate. You might want to get some chocolate in. Any other guesses? Shopping. Yeah, retail therapy might help. Sick leave. Yeah, you'll definitely want to take some time off. Shall we see? So, information guru Lee Byron and myself, we scraped 10,000 status Facebook updates for the phrase break up and broken up. And this was the pattern we found. People clearing out for spring break. Coming out of very bad weekends on the Monday. Being single over the summer. And then the lowest day of the year, of course, Christmas Day. Who would do that? So there's a titanic amount of data out there now, unprecedented. But if you ask the right kind of question or you work it in the right kind of way, interesting things can emerge. So information is beautiful, data is beautiful. I wonder if I could make my life beautiful. And here's my visual CV. I'm not quite sure I've succeeded. Pretty blocky, colors aren't that great. But I wanted to convey something to you. I started as a programmer and then I worked as a writer for many years, about 20 years in print, online, and in advertising. And only recently have I started designing. And I've never been to design school. I've never studied art or anything. I just kind of learned through doing. And when I started designing, I discovered an odd thing about myself. I already knew how to design, but it wasn't like I was amazingly brilliant at it, but more like I was sensitive to the ideas of grids and space and alignment and typography. It's almost like being exposed to all this media over the years had instilled a kind of dormant design literacy in me. And I don't feel like I'm unique. I feel like every day, all of us now are being blasted by information design. It's being poured into our eyes through the web. And we're all visualizers now, and we're all demanding a visual aspect to our information. And there's something almost quite magical about visual information. It's effortless. It literally pours in. And if you're navigating a dense information jungle, coming across a beautiful graphic or a lovely data visualization, it's a relief. It's like coming across a clearing in the jungle. And I was curious about this, so it led me to the work of a Danish physicist called Tor Noritranders. He converted the bandwidth of the senses into computer terms. So here we go. This is your senses pouring into your senses every second. Your sense of sight is the fastest. It has the same bandwidth as a computer network. Then you have touch, about the speed of a USB key. And then you have hearing and smell, which is the throughput of a hard disk. And then you have poor old taste, which is like barely the throughput of a pocket calculator. And that little square in the corner, 0.7%, that's the amount we're actually aware of. So a lot of your vision is pouring, the bulk of it is visual, and it's pouring in, it's unconscious. And the eye is exquisitely sensitive to patterns in variations in color, shape, and pattern. It loves them, it calls them beautiful. It's the language of the eye. And if you combine the language of the eye with the language of the mind, which is about words and numbers and concepts, you start speaking two languages simultaneously, each enhancing the other. So you have the eye, and then you drop in the concepts, and that whole thing, it's two languages both working at the same time. So we can use this new kind of language, if you like, to alter our perspective or change our views. Let me ask you a simple question with a really simple answer. Who has the biggest military budget? It's got to be America, right? Massive. 609 billion in 2008, 607 rather. So massive, in fact, that it can contain all the other military budgets in the world inside itself. Gobble, 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 gobble. Now, you can see Africa's total debt there and the UK budget deficit for reference. So that might well chime with your view that America is a sort of warmongering military machine out to overpower the world with its huge industrial and military complex. But is it true that America has the biggest military budget? Because America is an incredibly rich country. In fact, it's so massively rich that it can contain the 4 other top industrialized nations' economies inside itself. It's so vastly rich. So its military budget is bound to be enormous. So to be fair and to alter our perspective, we have to bring in another data set. That data set is GDP, or what the country's earning. Who has the biggest budget as a proportion of GDP? Let's have a look. That changes the picture considerably. Other countries pop into view that you perhaps weren't considering, and America drops into 8th. And you can also do this with soldiers. Who has the most soldiers? It's got to be China, of course, 2.1 million. Again, chiming with your view that China has a militarized regime ready to, mobilize its enormous forces. But of course, China has an enormous population. So if we do the same, we see a radically different picture. China drops to 124th. It actually has a tiny army when you take other data into consideration. So absolute figures like the military budget in a connected world kind of don't give you the whole picture. They're not as true as they could be. We need relative figures that are connected to other data so that we can see a fuller picture. And then that can lead to us changing our perspective. As Hans Rosling, the master, my master, said, let the data set change your mindset. And if that can do that, maybe it can also change your behavior. Take a look at this one. I'm a bit of a health nut. I love kind of like taking supplements and being fit, but I can never understand what's going on in terms of evidence. There's always conflicting evidence. Should I take vitamin C? Should we take in wheatgrass? So this is a visualization of all the evidence for nutritional supplements. This kind of diagram is called a balloon race. So the higher up the image, the more evidence there is for each supplement. And the bubbles correspond to popularity as regards to Google hits. So you can kind of immediately apprehend the relationship between efficacy and popularity. But you can also, if you grade the evidence, sort of do a worth it line. And so supplements above this line are worth investigating, but only for the conditions listed below. And then supplements below the line are perhaps not worth investigating. Now, this image constitutes a huge amount of work. We scraped like 1,000 studies from PubMed, the biomedical database, and we compiled them and graded them all. And it was incredibly frustrating for me because I had a book of 250 visualizations to do for my book. And I spent a month doing this, and I'd only filled 2 pages. But what it points to is that visualizing information like this is a form of knowledge compression. It's a way of squeezing an enormous amount of information and understanding into a small space. And once you've curated that data, and once you clean that data, and once it's there, you can do cool stuff like this. So I converted this into an interactive app. So I can now generate this application online, this visualization online. And I can say, yeah, brilliant. So it spawns itself. And then I can say, well, just show me the stuff that affects heart health. So let's filter that out. So heart is filtered out, so I can see if I'm curious about that. I think, no, I don't want to take any synthetics. I just want to see plants and just show me herbs and plants. There we go, all the natural ingredients. Now this app is spawning itself from the data. The data is all stored in a Google Doc, and it's literally generating itself from that data. So the data is now alive. This is a living image, and I can update it in a second. New evidence comes out. I just change a row on a spreadsheet. Douche. Again, the image recreates itself. So it's cool. It's kind of living. But it kind of can go beyond data, and it can go beyond numbers. And I like to apply information visualization to ideas and concepts. This is a visualization of the political spectrum, an attempt for me to try and understand how it works and how the ideas percolate down from government into society and culture, into families, into individuals, into their beliefs, and then back round again in a cycle. What I love about this image is it's made up of concepts that explores our worldviews, and it helps us, it helps me anyway, to see what others think and to see where they're coming from. And it feels just incredibly cool to do that. And what was most exciting for me designing this was that when I was designing this image, I desperately wanted this side, the left side, to be better than the right side, being a kind of journalist, left-leaning person. But I couldn't, because I would have created a lopsided, biased diagram. So in order to really create a full image, I had to honor the perspectives on the right-hand side, and at the same time, kind of uncomfortably recognize how many of those qualities were actually in me, which is very, very annoying and uncomfortable. But not too uncomfortable, because there's something unthreatening about seeing a political perspective versus being told or forced to listen to one. It's actually, you're capable of holding conflicting viewpoints joyously when you can see them. It's even fun to engage with them because it's visual. That's what's exciting for me, seeing how data can change my perspective and change my mind midstream. Beautiful, lovely data. So just to wrap up, I want to say that it feels to me that design is about solving problems and providing elegant solutions. And information design is about solving information problems. And it feels like we have a lot of information problems in our society at the moment, from the overload and the saturation to the breakdown of trust and reliability and runaway skepticism and lack of transparency, or even just interestingness. I mean, I find information just too interesting. It has a magnetic quality that draws me in. So visualizing information can give us a very quick solution to those kinds of problems. And even when the information is terrible, the visual can be quite beautiful. And often we can get clarity or the answer to a simple question very quickly, like this one. The recent Icelandic volcano, which was emitting the most CO2? Was it the plains or the volcano? The grounded plains or the volcano? So we can have a look. We look at the data and we see, yep, the volcano emitted 150,000 tons. The grounded plain would have emitted 345,000 if they were in the sky. So essentially, we had our first carbon neutral volcano. Yeah. And that is beautiful. Thank you.
Right. Okay. So that's where we're going. That's what we're doing, folks. So, um, what I want, go into Canvas. Here's the description of the project. So, I mean, this is going to be like a 2-week project. And you are going to need some data to work with. You're going to be creating your own data visualization. I think it's really interesting if you collect your own data. So maybe for the next 2 weeks on your phone or get a notebook or something, just start documenting something about your life. It could be your sleep. It could be your diet, what you're eating, how much coffee you're drinking, how much exercise you're giving, where you travel, how much money you spend, your mood, I had a student do a really interesting data visualization about she was prone to migraines. So she recorded, how many migraines and the intensity of them, and used that data for her visualization. It's really interesting if you can, if you really sit down and get creative, you can come up with, if you can combine maybe 2 or more data sets. So, not just how many cups of coffee am I drinking, but also then record how much sleep you're getting. And then you compare those two and look for correlations. Something like that, how much money do you spend when you're out and about town versus when you're staying home, or something like that. You guys uh, can get creative with it. If you don't want to collect your own data, I have, oops, no, this one right here. I do have some resources for you. If you go to this page here, data sets, this is a really interesting project this guy does. He just researches data sets that he finds online. Hold on, I see something. Camilla's asking me, is there a link to that diagram? What diagram? Wait, I can't read this stupid thing.
It was a diagram in the TED Talk that I wanted to take a closer look at.
If you go to, he has a website and I think it's called Information is Beautiful. And a lot of that stuff is on that website. So
Oh, okay.
for
Thank you.
Information is Beautiful. It's really good. So yeah, so this is a spreadsheet started, in 2001, and it goes on and on and on and on forever. And it's just all sorts of interesting data, and it's got links over on the side here where you can find data. Comes in all different sizes and shapes. Sometimes you can just download a CSV file, which stands for comma separated values, and use that. Sometimes it's a PDF and you have to kind of like scrape the data out of the PDF. Sometimes it's a website. But there's lots of different methods. If we have time in the semester, we'll go through, how to deal with the different data sets. But yeah, so this is here for you too, if you want to explore these, relative living standards, hunter-gatherers, oil concessions. What was that? German traffic signs? German traffic signs. Interesting. Okay. All right. A whole bunch of traffic signs. Great. Anyway, that's there for you if you want to, or you can find your own. You can do your own research. But you want to have some sort of data set, I mean, it would be nice, the more data you have, the more, you know, effective your visualization is going to be. So, try to get 50's good, 100's good. See what you can pull together. But that's all available to you, and then you're going to make a great visualization. So okay, now we haven't even started to talk about how this works in code. Let's do that. Okay, I'm gonna go over here. We're gonna crack open our favorite website and create a sketch. Okay, so we are going to be learning how to create arrays and use arrays. An array is basically just a list. Okay, so let's say it's a list of numbers or a list of words or something like that. So to create an array, we're going to be using our square brackets. That's symbolizes, start square bracket, then you put all your data, and then you end the square bracket. So I'm going to create an array right before your eyes, right here. Okay, you got to give it a name. So an array, you can think of it as it's kind of like it's actually technically it's an object. It's kind of like, but we're creating it like we would create a variable. So I'm going to say nums. So I'm just going to make an array of numbers. So I'm going to start with a square bracket, and then I'm just going to add some numbers. I'm going to say 20, 12. I'm just making up numbers here. 78, 102. Okay. Okay. I just created, I need an equal sign. Oh, very important. Okay. So we have created array. So now if I wanted to view that array, I could just do something like console.log, and then I'll just put the name of the array. Okay. And then we'll run that. And this is what I get. It basically spews back to me exactly what I entered. But here's the interesting part. What if I do console.log nums, and then I put my square brackets in there, and now I'm going to give it a number. I'll explain this in a second. I'm going to say nums2. Okay, I'm going to run that. What is the result I'm getting? It's giving me the value of 78. Okay, 78 is in my list. What I have done is I have just reached into, by doing that right there, bracket to bracket, I've reached into the array and extracted a specific value. Okay, why 2? Okay, well, let me explain how this works. Arrays, they have a length, right? This array has a length of 4, right? There are 4 items in the array. Each item has a specific index number. Okay, so to demonstrate this, I did a little diagram in Illustrator since I don't have a whiteboard. Okay, so let's say this is my array right here. Okay, this array has 15 numbers in it. Okay, so the length of the nums array is 15. However, each item in the array has an index number, and that index number starts with 0. I know this is confusing. This is computers. Welcome to your life. In computer science, we start counting with 0. It's just the way it is. So the very first number on the array is 7. So when I said, give me the value, the item at index number 2, which is what I asked for here, it went 0, 1, 2, and gave me the number 78. Okay, this is just something, we need to get used to, right? So there you go. Da, 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 da. For the 15th item on this array is actually at the index number of 14. You'll get used to it. You'll get used to it. It's okay. It actually turns out pretty well because we're going to combine arrays with loops. And if you start a loop at 0, there you go. You're all set. So you just something you get used to. 0, index 0. So if I went in here, now I've got these nums. Okay. So let's use these for something. Let's say let's make some circles on the screen. Okay. We'll say ellipse, and we'll go down 3. Let's see. The x value will be 100, and go down 300, and then for the first circle we'll say nums 0, and then we're going to do that 4 times. Just move them over a little bit each time, maybe. I don't know if this is going to work. I have one that's over 100. Okay, well, we'll try that. And then I'm just going to go down and keep. So this should produce 4 circles across the screen, and each one is going to have the size of whatever value I'm extracting from that array. So let's see if this works. Boom. Dun, dun, dun. There you go. That, my friends, is it's kind of the start of a data visualization in a way. Like, what if these numbers right here represented, I don't know, average how do you measure rain? Inches? The average rain values for the year or the month or something like that. And you could visualize, how things were progressing. Yeah. So, you can just plug that into anywhere you would put a variable, plug it in, and you're done. We can also do things like, what if I did this? I added a word, lava, chicken, and then I could do something like text. I know it's not a number and it doesn't really make any sense, but that would be 0, 1, 2, 3, 4. That would be position 4. Right, and then I'll do that at like 400. It's gonna be black and hard to read, but whatever. And then, yeah, there we go. And, so it's just data like you've been working with, but it's just a way of consolidating data into, lists and groups and things like that. Yeah. Okay, but as you know, because you've taken my classes before, anytime you find yourself typing the same thing over and over again, there's probably a better way to do it, right? Yeah. So let's go back a few weeks or months to when you learn loops. So loops go so good with arrays. They're kind of meant for each other. So let's make a loop to go through those numbers instead of a line of code for each one, because in a lot of situations, you may not know how many things are in the array. Arrays are dynamic. You could have a game where every time someone clicks, a new object is born, and that object needs to be stored in an array somewhere. So you might not know how many things are in the array. So let's make a loop for it. Okay. So if you recall, I knew this might be a little bit of a refresh here, but okay. A for loop, right? Okay. For, remember there's 3 parts to the setup here. First, we initialize a variable I. Why we call it I? We just do. That's just what we do. Let I equal 0. Start it at 0. Semicolon. Okay. As long as I is less than 4. Okay. 1, 2, 3, 4. Okay, well, hold on. Yeah, okay. Was I less than 4? And then I want it to increase. So it's going to start at 0, then go to 1, then go to 2, then go to 3. That's why the number 4. Because as soon as it hits 4, we don't want the code to work anymore because, it's, oh wait, why do I have a parenthesis there? That doesn't make sense. Okay. And then, okay, so we're increasing by 1, right? Okay, all right. So this is going to loop 4 times. Because we're starting with 0. Now, all we have to do is ellipse. I'll come back to that X value in a second because you probably already realized there might be a problem. Okay. And then right here, I'm going to say nums I. So each time through the loop, it's going to grab the next number on the list. So it's going to go 0, 1, 2, 3. Boom, 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 4 times. Okay. The reason I mentioned this number here is because we can't draw them all at the exact same location, right? 100, 400. So we're going to need to, but you've done this before, you've done loops. So we're going to need to do something like, and one solution is I times 100. Okay. That's not perfect yet, but let's run it and we'll change it. So I'm going to run it. There we go. So in much less code, and imagine you had 100 things on your list, much less code, we are able to run through the list and do that. And now the problem here is that, the first number is 0. What is 0 times 100? Say it with me. 0. Okay, so starting at 0. So we kind of need to do one more thing here. We're just going to shift them all over by 100, just, and that's fine. We do that, and we get that. And it all works out. It all works out. So, for your first exercise, what I want you to do is, over here. For your first exercise, you make a grocery list. Yeah, fun, right? This is useful. You can do this. Make a grocery list. So you're gonna make an array. This array is going to be full of words, so strings. So, if we're dealing with, like text characters, we got to put it between quotation marks. And remember that every element on the array needs to be separated by a comma. Okay, so create yourself an array of your grocery list items. And then in the draw loop, create a loop. I'm going back. Okay, stop. Pause. Let me show you one more thing. Okay, in this scenario right here, right, I've got this nums array, and I already know how many things are in it. 4. What if I didn't know? Okay, there's a solution to that. like I said before, arrays are actually technically objects. So there's actually stored information about an array and functions too that we can use. And one of those functions is you can actually access the length of an array. Yeah, I'll prove it to you right here. Okay, I'm just going to do console.log, and I'm just going to put the name of the array. And then I'm going to put dot. Remember the dot syntax? Like when we worked with objects, that's how you access data and functionality inside of the objects. I'm going to do dot and then length. And then run that. And it's coming back with a number 4. Even though it only goes 0 through 3, it knows that its length is 4. It's not confused about that. So let's use that instead. Instead of 4, we're just going to say nums dot length. So now I could actually add, more, more numbers to here, and it would still work. It dynamically updates, it knows its length, and because I've created this loop that automatically shifts them over, I run it and boom, it works perfectly. I could add more numbers, I could delete numbers, and it would still work. So that's what that's something you can do with this exercise right here, okay? All right, so I've created there's the collection. Please, as soon as you're done with this, update it in the collections because I'm not there in the room to walk around and see if you've done it. So that tells me that, yeah, you guys got it. We can move on into the next one, okay? Any questions? Anything in the chat? Think you can do this? Okay, go ahead. And then, as always, if you have any problems, just speak up, just say something. I can go into open processing and look at your code, and someone else is probably having the same problem, so don't worry about that. Dang, it's already hot. Can you imagine if we were in the classroom right now? It'd probably be miserable. Oh, another thing that I think about too is that you can might be able to extract data about yourself from your phone, like if you have any like fitness trackers, or some people use trackers and like books they read or screen time. Oh yeah, you can definitely. I know on the iPhone you can look up your screen time. You could look up stuff like that. So that might be fun to play with. Okay, I got a couple people. Oh, wow. Andres already has the second one done. Very good. Awesome. Yeah, I need a sense of how you guys are doing. Give me a thumbs up if you want to move on to the next one if you need yeah, thumbs up if you want to move on to the next one. Don't say anything if you need a few more minutes. Okay.
Hello, Rusty.
Hello.
Hi. I have an appointment right now, so I'm gonna head out.
Okay.
Will there be class on Monday, like usual?
Yes, there will. And I'm recording this and I'm going to post it. So come, when you have a chance,
All right, thank you.
come
Bye-bye.
back and yeah,
Have a good
watch the
weekend.
rest of it. Okay.
Have a good weekend. Bye.
Thank you. Oh, you're going to show, right?
Yes.
Okay, good. Great. We got a few more. Okay, good. Okay. Give you a couple more minutes and then we'll uh uh Okay, I'm gonna have you put that on pause. You can always come back to this video if you need to refresh. Um, what I want to show you now is um what am I trying to say? Okay, arrays get really powerful when you combine them with loops, of course, but what if you filled an array with objects? Okay. Or, well, we're not going to do that right now. Now I'm totally jumping ahead of myself. No. What I want to show you is now, sometimes you don't know what's in an array before you create it. Okay. It might get filled with things over time. And how do we, how do we do that? There's various ways to do it. But what I'm going to do now, and let's see, what's the best way to go about this? I'm going to do the same thing here with these numbers controlling the size of the circle, but I want those numbers to be generated randomly. Okay. So it's not necessarily a data visualization because it's random data, which has no meaning really, but we're going to do it anyway. So instead of typing out, by hand all the values, I'm just going to start with an empty array. So I'm just going to start. I need to initialize an array, but I don't actually have to tell it what's inside the array. That can come later. So I'm just going to say nums equals empty array. So just brackets, nothing in it. Okay. And then what I'm going to do in the setup, because I really only want this to happen once, I'm going to make a loop that fills that array with random numbers. Okay, I'm going to do this in the setup. So I'm going to say for let I equal 0. As long as I is less than how many items, how many times do we want this loop to happen? How many items do we want to create? I'm going to say, what is this, 6 right here? I'll say 6 then. Okay. So as long as it's 6, and then as long as I is less than 6, and then I plus plus. Okay. Okay, so this is gonna lead, this is a loop that happens 6 times. So in this case, I'm going to, well, first I'm going to generate a random number, rando equals random, let's say somewhere between 10 and 80. Okay, we have a random number. And then now, in order to, put, excuse me. Okay, it might happen again. It might happen again. Okay, wait, maybe. Okay, all right, I'm good. So in order to place a value at a specific place in an array, I'm going to just, all I have to say is nums. And then if I did something like this, right? I said nums 2, equals 4. Okay, this doesn't really make sense in an array. I'm just trying to make the point that this line of code right here would put the number 4 in the 1, 2, basically the third position on the array, index number 2. Okay, which would be a third position. So that's, that's how you could just like hard code a number into an array. You can do that. What we're gonna do is we're gonna say instead of 2, we want it to fill up the array. So we're gonna say I. So every time through the loop, it's going to put it in position 0, then 1, then 2, then 3, all the way up. And then we don't want them all to be 4, obviously. We want them to be that nice random number that we just generated. So every time through this loop, a new number is going to be pumped into the array. And let's see what happens. See that? So every time I rerun this, the sketch, I have a new set of random numbers and they're getting drawn to the screen as circles. Okay. So that's how you kind of like generate a new array if you needed to do that, So for this next exercise, okay, you're going to be doing something very simple. You want a whole bunch of lines drawn one after the other, and then they're all connected to each other. Okay. The way you can do that is just think it through. Okay. If you had a list of 100 numbers that you could use for the X position, and then you had a list of 100 numbers that you could use for the Y position, you would have 100 positions, right? What am I trying to say? Okay, so basically you need to do what I just did. You need to make a loop in the setup that loops 100 times, and you probably want like to do like random X for one of the, random width, so pick something on the screen, do that for the first array. So you have an array of X positions, then make an array for Y positions. So it would be random height, right? Store those numbers into an array. So name them, I don't know, X's and what, I don't know, name them whatever you want. And then you've made those 2 arrays, you've got the data, now you need to do something with it. That brings me to this, this line, this next step right here in the draw. You might want to in the draw, you're going to need to make a loop that goes through all of those numbers. Okay, there's a little bit of a trick to this, okay? You're going to be drawing a line from one point to another point, and then you're going to draw a line from that same point to another point. So you're going to be going through these lists of X and Y positions. And you takes a little, okay, you got to really think about this because you need 2, to draw a line, right? You need 2 points on the screen. Okay. Maybe I should demonstrate this. You need 2 points on the screen, right? So if I had like, X's, and then I had Y's. That's a weird way to spell it, but okay. I'm gonna make up numbers for now. I'm just gonna say like 643, 502, 2. Okay, let's use those number, and then down here, I'll put like 200, 5, yeah, 501, and 33. Okay, so I've got a bunch of X positions and a bunch of Y positions, right? So if I wanted to draw a line between, you know, if I wanted to use those points to draw lines, how would I do it? Well, for trying to think of the best way to explain this. If I did the line function, for example, line, I could access, okay, X is 0, okay. That's the first X, okay? And let's pair that up with the first Y. Y is 0, okay? That works. Now we need the second point for our line. I can't just do X is 0 and Y is 0 again because it's the same exact point. We need a different position on the screen. So I'm going to jump to the next value on the list. So I'm going to say X is 1 and the next Y value 1. Okay. And draw that line. And what happened here? On M-N-S. Oh, did I spell it wrong? What did I do wrong? Using nums instead of. Oh, I still have that code up there. Sorry. Get rid of that. Okay. Okay. Now I'll run it. No, okay, there we go. So I got a line from 200 to 645. Okay. So the trick for you is first generate a list, those numbers, you know, write a loop and make random numbers and stick them in the array. And then the trick to it is you're going to, this line of code right here, line is actually going to be inside of a loop. So you're not going to use 0 and 1 are actual numbers. You need to use I, right? The number that's changing over time, right? So you're going to need to modify I a bit to get the second point. So if the first point is I, right? That's not an I. If I'm in the loop, I'm just pretending like I'm in a loop right now. For blah, blah, blah. Okay. You know, what does this need to be? Because if we say I, it's the exact same point as that position. So what can we do to I to get the next position? There's a teeny little bit of math, tiny little bit of math you got to do to the I value to get the next number in the list. And I'll let you figure that out, okay? Any questions? I'm in the chat. Oh, okay. Thank you, Marty. Yay! Yay, Karina did it. Oh, awesome. Well, wait. No, Karina. Your lines aren't connecting. What's going on here? Let's take a look. Look at your code. Okay. You. Why are they connecting? Excellent. Okay. Why? Oops. You made 150, made a loop, and you did line length. That's good. So line X, Y. Oh, you did Y plus 1, and then Y plus 2. Maybe that's it. Let's change this to 1 and see if that fixes it. Yes, now they're all connected. Yeah, you only needed to do each one of them only needed to go up by 1. You didn't need to go up by 2 because they're 2 different lists. So now they all connect. Yeah. Now I'm kind of surprised that did you get an error? Yeah, you do have. Wait, what does that say? Line 20. It's on line 20, this one right here. You did have some sort of an error, and I think the reason is that when you get to the end, when you get to the very end of the array as it's looping through, it's still going to take the last number and add 1, which is actually there is no more. Like we got to the end of the array. We're at the last index number and then we add 1. I'm surprised it actually worked and it was just a very mild um uh uh error. But one thing you can do to prevent that is you could change this right here where it says dot length, you could say dot length minus 1. So I will never actually get to the final number, but you will because down here you added 1 to I. So you actually are getting everything out of the array, but you're avoiding any kind of errors. I mean, the error didn't stop this from running, but who knows, on somebody else's computer, it might not work, but it worked here, so that's fine. Yeah, looks great. And Andres has got all the balls working. Ooh, and they're poppable. Ooh. Fun. And pop them all. Boom, 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 boom. And game over. Oh, I didn't get a game over. My bad. It's my code anyway, so it doesn't matter. If you use my code, I don't know. Oh, it's okay if the game over text doesn't show up. It might have been, I don't know, Andres, if you use the code that I provided. Yeah, I don't know. Let me see. Might be there, might not. I can't remember. Yeah, I don't think I had a game over screen in this code, and that's fine. That's fine. But if you were to add a gain or a strain, then you would need some sort of counter, and it would make sense to let the counter equal the array length, right? So could do that. Um, I'll be right back. I have to plug in my laptop. We have one more. Yay, Ryan got it. Cool. Okay. Okay, I'll give you guys more time because I only see two submitted sketches. Uh, it's 11:32. I'm wondering if we have time for this last one, because this one gets into um um putting objects into an array, which is really, I mean, and not that hard. How are you guys feeling confidence wise with moving on? Or do you just want to just absorb all of this for now and we do it on Monday? What does that mean, Ryan? Is that yes, you want to move on? Okay. Anyone else? Mm. Not looking like it. Okay. I think that's fine because we still have, I'm not gonna make this is not due next week. Obviously it's Friday, that would, yeah, no. We're gonna have Monday and Wednesday for instruction, and then we'll on finals week we'll go over them. Okay. Right, and if you want to go ahead and tackle this whole using arrays with objects thing, you can go into and watch Dan Schiffman's video if you go to arrays coursework and his playlist here. I think it's like 7 arrays of objects right here, 7.3. It will shine some light on how we do that. So maybe I'll hold on to this one for next week because yeah, it's very powerful and we want to really master it. So I don't want to just, brush through it this time. Not this time. How are we doing here? Uh-huh, uh-huh. Hmm. Okay, so we've kind of established that we're gonna call it here. Just work on these two exercises and then we'll get to objects on Monday. So I'm going to stop recording. Stop recording. How do I do that? How do I do that? Stop recording. Yeah, here we go. Okay.